Hello 7th graders and welcome to Math Weekly number 3 where our focus skill will be measures of central tendency and variability. Although central tendency and variability may be new terms for you, you will find that you already know how to calculate 4 of the 5 types of calculations that fall in these two categories. Let's begin with central tendency, which will be the most familiar to you. The definition is central tendency describes where the center of a set of data lies. Where's the middle value? There are two types of calculations that result in a description of the center. The first is the mean. Mean is also known as average. To calculate this, add all the numbers in the dataset and divide by the total number in the dataset. The second type of central tendency is median, where you order all the numbers in the dataset from least to greatest and find the middle number. Let's now look at a sample question which requires us to use measures of central tendency. Just as a side note, we will use this problem again for variability because all of these types of measurements can be used with these numeric data. The junior high baseball team scored the following number of runs in their games last season: 6, 2, 5, 9, 11, 4, 9, 6, 13, and 5. The question asks, how much greater is the mean than the median? So you can see that our number one goal is a comparison of how much greater one is than the other. So this is our goal, to compare. But before we can compare, we need to make these two calculations so that we know what value these have in terms of runs scored. So let's begin with the mean. Remember, mean is also known as average, which means to add all the numbers and divide by how many there are. So we have 6, which is the first number in our set, their first game, plus 2 more, which is their second game, so that'd be 8, plus 5, which is their third game, 13, plus 9, which is 22, and I'm just going down their game score list, plus 11 is 33, plus 4 more is 37, plus 9 makes 46, plus 6 makes 52, plus 13 makes 65, plus 5 more makes 70. Now this is the sum, this is the total runs. So there's 70 total runs, and those were split, which means the divide, between 10 games. So the mean is 7 runs per game. That's the average. The average game was 7 runs per game. Does that mean that they scored 7 runs in every game? No. But if they had scored the same in every game, it would be 7. Now our second calculation that we need is the median. The median requires us to order the numbers from least to greatest and find the middle value. So our lowest is 2, then we have 4, 2 5s, so 5, 5, 2 6s, so 6 and 6, 2 9s, 9 and 9, and 11 and 13. And then I just like to double check that I have all 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that half of 10 is 5, so if I would begin crossing beginning, end, beginning and end, beginning and end, beginning and end, beginning and end, we can find the middle here, which splits 5 to the left and 5 to the right. Well, what number is between 6 and 6? 6. So the median, the middle value, was 6 runs. Now, it asks, how much greater is the mean than the median? Well, how much more is 7 than 6? 1. So the mean is 1 greater than the median. Notice our goal always was to compare, but required those two measures of central tendency, which calculated center values in two different ways. Now let's look at variability. The definition of variability is how spread out the data is. How much does it vary between that minimum and maximum, or how much does it vary in the interquartile range, or how much does it vary from the mean? There are three types of variability measurements. The first is the range. The range means to subtract the minimum and maximum values. So if the highest they scored was 13 and the lowest they scored was 2, 13 minus 2 is 11. The range would be 11 runs. So their scores ranged 11 different values. The interquartile requires you to subtract or find the difference between the lower and upper quartiles. So just like we did when we made box and whisker plots last week, we would find those lower and upper quarters and we would subtract them. We're not going to do any examples with these because you can look back to that box and whisker plot lesson to figure out where the minimum and maximum values are and where the lower and upper quartiles are, and then you just need to know to subtract them. What we are going to focus on is a completely new measure of variability, which is called the mean absolute deviation, which in essence is the average distance each data value is from the mean. How far is each one from the average? So here are the steps to calculating the mean absolute deviation. There are 3 steps. First, calculate the mean. Add them all up, divide by how many there are. Second, calculate the absolute deviation each value is from the mean. So if the mean is 7, and in the game they scored 9, their absolute deviation would be 2 because they scored 2 different from the mean. And third, calculate the mean absolute deviation by calculating the average of the absolute deviation values. Note, using the chart on the next example will always help you calculate the mean absolute deviation. So when you are asked to do this on your Math Weekly, please use this chart as an example. So here I have the same question that we just worked with when we were talking about central tendency. I have already shown us step 1, which is to calculate the mean because we did it earlier in the video. So if the mean is 7 runs, calculate the mean absolute deviation. This is the organizational chart that I was telling you about. It has the runs across the top, and this doesn't always have to be runs. It could be test scores or favorite number or number of siblings or whatever it is that you're studying. So across the top we have the runs. The center we have the mean. Our mean was 7 runs, so I put 7 in every column. Now this third row is going to help us to calculate or do step 2, which is find the absolute deviation. How far is each one of these game scores from the mean? Well, 6 is how far away from 7. Well, that's 1 different. 2 is how far from 7. That's 5 different. 5 is how far from 7. That's 2 different. 9 is how far from 7. That's 2 different. 11 is how far from 7. That's 4 different. 4 is how far from 7. That's 3 different. 9 to 7 is 2 values. 6 to 7 is 1 value. 13 to 7 is 6 higher than average. And 5 to 7 is 2 lower than average. Now this was step 2. Just see how far each data value is away from the mean. Our next step is to calculate the average of these. So we're going to take these 10 numbers, these ones that tell us how far they are from the mean, add them all up and divide by how many there are. So 1 plus 5 makes 6. 6 plus 2 makes 8. 8 plus 2 makes 10. 10 plus 4 makes 14. Plus 3 makes 17. Plus 2 more is 19. Plus 1 more is 20. Plus 6 more makes 26. Plus 2 more makes 28. So if you add up the distance that they are different from the average, there are 28 differences between all 10 games. So if we take our 28 differences and divide it by 10, each one was about 2.8 runs away from 7, which was our average. So our mean absolute deviation is 2.8 runs. So let's summarize what we've learned. We've learned that central tendency describes the center of the data, and that variability describes the spread of the data. We learned 2 measures for central tendency, which were mean and median, and 3 for variability, which were range, interquartile range, and mean absolute deviation.